Alright, welcome guys, and this is gonna be a start of a playlist filled with knowledge and filled with physics. Mainly physics, because I like physics. Today I'm gonna be telling you about dimensional formulas. If you've never heard of them, dimensional formulas are mainly used to make sure that a formula or an equation used to obtain some sort of physical quantity, whether it's a scalar or a vector quantity, to make sure that that way of obtaining it using that specific formula or equation is correct. So here I have the formula for density, and I'm pretty sure you've seen it before. Now, the way that we think about dimensional formulas isn't only to figure out an equation is correct or wrong to obtain that some sort of like physical scalar or vector quantity. Another thing that we can obtain is that we can use the same way is by simplifying. We can so the way of getting a dimensional formula is that we simplify things. So for example, if I told you to write the area equation in which the area is equal to the length times the width. I'm pretty sure you've heard it before. It's a pretty standard one, you know? You're gonna tell me, okay, well, what? You see, buddy, in a dimensional formula, you simplify things. Right, so how about I want you, actually, I'll just do it. So let's just write down the area one. So yeah, as I said, it's L times W. And in a dimensional formula, a width is a length. Hold on. Isn't a width also a length? It's some sort of distance. So L times L, that's, hold on. Yep. So L times L, that's literally L squared. Alright? And that's how you get a dimensional formula. You simplify things to their most. Like, you see, of like, if this some sort of physical quantity, whether a vector or a scalar quantity, if it's made up of other scalar or vector quantities, you see how simple it is. Like the volume, what is the volume equal to? L times L times L, the length times the width times the height. So L, that's a length, W, width, that's length, and height is length. So L times L times L, that's L cubic. Now, I want you to try to solve the density dimensional formula. And if you get something like this, then yep, you're correct. But if you stop at that, you're wrong. You need to go all the way down because the true answer lies below. So as you see here, I split it up. M is it's not it's a stable one. It can decay like electrons. The mass is a quantity and it can decay into something else. So the mass, and as I said previously, the volume is L times L times L, which means that m to the power of 1 divided by L to the power of 3. So that's m power of 1 times L power of negative 3? What did we do here? In mathematics, for example, if you have 2 to the power of negative 1, you make the fraction upside down. So 2 to the power of negative 1 is 1 and a half, a half. Go do it right now in your calculator. So m to the power of 1 times L power of negative 3 is ml negative 3, and ml power of negative 3. And if you had numbers like that and you put it on a calculator, it's going to give you the exact same output as m to the power of 1 divided by L power of 3. Alright, now that's something. We can also use it to obtain a specific unit, like I said, like maybe Einstein's equation or something like that. But now, I just wrote down the acceleration one, and I wrote down the dimensional formula, and in the end I'm going to ask you to write the unit. So what you have here is that the formula for acceleration, if you've heard it before, is that it's delta v divided by delta t. And what is delta v? It's the velocity. And what is the velocity equal to? It's equal to the distance divided by the time. And isn't the distance a length? So length divided by time, as we said, it's going to be lt to the power of negative 1, alright? Because L to the power of 1 divided by t to the power of 1 is Lt to the power of negative 1. And then we know that delta v is equal to L to the power of negative 1. Now you see I wrote here t to the power of 1 in the bottom of the fraction so you understand why it's L to the power of negative 2. So in mathematics, again, when you have variables raised to a certain power, in division, you can subtract their powers. So you have negative 1 minus 1, that's L to the power of negative 2. Yep, that makes complete sense. So in the end, it's going to be LT to the power of negative 2 because negative 1 minus 1, that's the power in the bottom from the other t. Negative 1 minus 1 is 1. That's LT to the power of negative 2. Alright, it makes complete sense. Now, I want you in the comment section to tell me what did you think, because I might make another video and I might be talking about Newton's laws of motion. Like, if you look at the post I posted in the community, you'll understand why. And I want you also in the comment section to see if you can calculate the unit used for acceleration. And as I said, this is going to be a full playlist. So I want you to calculate the unit and the acceleration in the bottom without looking it up and showing me work. Alright, I hope you guys enjoyed. Have a great day. Make sure you're tuned for another video, and peace.